Alright, this is our second and last part to solving absolute value inequalities. Okay, our objective in this lesson is to write, solve, and graph absolute value inequalities, and we'll be doing absolute value inequalities with greater than. Alright, our vocabulary is the same as it was last time, so if you got it down then, you should be good. If you didn't, here's your second chance. So pause and, if you need to, get this information down. Alright, in our last lesson we were doing absolute value inequalities that contain the absolute value symbol and the less than symbol. So today we're going to be doing absolute value and greater than, or greater than or equal to. And just like the less than was an and compound inequality, greater than is an or compound inequality. Once again, I've written down the steps that you're going to follow to solve an absolute value inequality. So if you didn't write them down before, make sure you get them down this time, please. Alright, on this example, which we're going to solve, graph, and write in set builder interval notation, I'm going to walk through step by step on how to solve this absolute value and greater than inequality, and the rest of the ones I'll let you practice and check your answer with mine. So first of all, step one, question you ask yourself, is the absolute value bars by themselves on one side of the inequality? And if you look here, I have inside absolute value bars 2x plus 4, and on that side of the left side of the inequality there's nothing else there, so yes, they're by themselves. So that means I can skip on to step 2, which is take what's inside and write it 2 times. First time you keep everything outside the same, and the second time you flip or reverse everything outside the bars. And because this was absolute value and greater than, it is an or compound inequality. Alright, now why don't you see if you remember basically how to solve an or compound inequality. So let's just go ahead and pause the video and you solve that yourself. So pause the video now. Alright, I hope we got the same thing when we solved. Remember, all you do is solve the first inequality, then solve the second inequality, and then put the word or between the two answers. Now let's see if you remember how to graph an or compound inequality. So pause the video and give that a shot now. Alright, here's what I got for my graph. The one thing to keep in mind about an or compound inequality, and because it's greater than, we are using the or compound inequality, that anything that is shaded on either of my answer graphs has to be shaded on my final graph. So here's what your final graph should look like. Now pause and try and see if you can remember how to do the interval and set builder notation. Alright, so here's my interval and set builder notation. Remember, from the interval notation, it's always, where does my shading start? Where does my shading stop? Start point, comma, stop point. And I always start from reading the graph from the left to the right. So this is my start point, stop point. Start point, stop point. And I put parentheses around everything except for closed circles. Closed circles, I put brackets. So let's go to another example. Okay, this is our second example, and you'll notice that we have this multiplication of 3 and the addition of 5 outside the absolute value bars. And we can't go to step 2, which is write it twice, until we get rid of that. We need the bars by themselves. So I have to get rid of the addition of 5, and that gives me 3 times the absolute value of 2x minus 1 is greater than 21. And I've also got to get rid of this 3 here. Since this is in front of the absolute value bars, that means there's multiplication. So I undo it with division. So now I have the absolute value of 2x minus 1 is greater than 7. All right, now my bars are by themselves, so I can write it twice and then solve. So why don't you write it twice and then solve and then restart to check your answer. All right, this is my answer. So let's see, and if you can graph it and write the interval and set builder notation on your own. So pause the video and give that a shot and then restart to check. All right, here's my graph, my interval, my set builder notation. Check your work with mine. And if you have any questions about it, make sure you ask me in class. On to the next one. All right, here's the last example you're going to work through. And this one, our 4 steps we go through, the absolute value bars are already by themselves. So we would write it 2 times. Step 2, first time, keep everything outside the same. And second time, flip everything. But this one's a little tricky. 0 doesn't have a sign. So we flip the inequality and we just rewrite 0. So remember, no sign was 0, but we still do have to write it twice. One time with the greater than and one time with the less than symbol. And because it is absolute value and greater than, we write the word or between it. Now let's see what happens. You solve these 2 inequalities and restart after you do, and don't do anything else because we need to talk about this at that point. So stop and try to solve. Alright, here's my solution when I solve these 2 inequalities. I got x is greater than or equal to -5, or x is less than or equal to -5. Now let's graph each one of these individually and let's see what happens on our final graph. So first of all, my first one, I have a closed dot at -5 and my arrow points to the right, so I shade to the right. And then for my second answer, my second inequality, y is less than or equal to 5, I have a closed dot at -5 and it's shaded all the way to the left. All right, now remember I said with a or compound inequality, anything that's shaded from the answer of either of our 2 inequalities is shaded on our final graph. So what that means is my shading on my final graph is going to cover from -infinity all the way through to 5 because I got 2 closed dots, and then all the way up to +infinity. So my whole number line is shaded from -infinity to +infinity. So what that means for my interval notation and what that means here is that any real number is going to work in this inequality. So I can either write this 2 ways. I can write from -infinity to +infinity, and that's most likely the way you're going to see it. Or I can do a bold R, a bold looking R with a line down the middle. And that's the symbol that stands for all real numbers. And most likely, your set builder notation is going to say all real numbers also. So this is the graph when a solution has infinite solutions. Any real number will work. All right, finally, on for one less thing to think about. Okay, so this is the work that someone did when they solved the absolute value of -4 plus 1 is greater than 3. And this is their work. Now they did something wrong. So I want you to look at this and think about this. And I want you to, in your notes, describe and correct the error. And we're going to use this as a classroom discussion in class. So be prepared. See you then.